In this video, I'm going to simplify and explain piezo-resistive pressure sensors. Since the introduction of electronic control over fuel and ignition systems, pressure measurement has been required. Most early systems used a mechanical pressure sensor consisting of a diaphragm connected to a potentiometer. As the diaphragm moved due to the pressure change, so did the resistance value of the potentiometer. These older type sensors are not suitable for modern vehicle electronic signals as they are too slow and imprecise. Because of the demand for lower exhaust emissions and increased fuel economy in modern vehicles, manufacturers require extremely accurate signals from engine sensors. To achieve more accurate signal inputs to the engine control module, manufacturers have turned to piezo technology. This technology has been integrated into many types of pressure sensor. Some examples of these pressure sensors are manifold absolute pressure, barometric pressure, fuel rail pressure, exhaust pressure, turbo boost pressure, EGR differential pressure, air conditioning pressure sensors, and so on. The reason these sensors are so accurate is that they use a piezo crystal strain gauge. The sensing material in a piezo-resistive strain gauge is a diaphragm formed on a piezo silicon substrate, which flexes with applied positive or negative pressure. When flexing, the substrate material deforms, causing a change in the structure of the piezo crystals. This change in structure results in a resistance change in the material. Although this change is relatively small, the measurement of this change is extremely accurate. We could measure this change directly off the strain gauge. I'll demonstrate. To improve accuracy and stability of these measurements, the piezo-resistive strain gauge is coupled to a Wheatstone bridge. A Wheatstone bridge is nothing more than two simple series circuits connected in parallel. Let's look at this now. I have 4 resistors of the same value mounted on a test board, labelled R1, R2, R3 and R4. Just like in a vehicle's ECM, I will supply 5 volts to the junction of R1 and R2. I will connect the low reference or ground to the junction of R3 and R4. I'll now connect a digital multimeter set on volts to the junction of R1 and R3 and the junction of R2 and R4. The meter displays 0 volts because the circuit is balanced and is displaying the potential difference between the 2 series circuits. The potential difference is 0 because all the resistors have the same value. In a working Wheatstone bridge, there will be a sensing resistor, a trimming resistor, and 2 fixed resistors. The trimming resistor is used to balance the bridge. If the sensing resistor value was to change, the circuit would become unbalanced and the meter would display this difference as a voltage. A very small change in the sensing resistor can now be converted to a voltage across the Wheatstone bridge. I'll use a light dependent resistor, or LDR, as my sensing resistor. I have a potentiometer as my trimming resistor. I'll use it to balance the circuit. Any change in the circuit can be seen as a voltage. The beauty of using a Wheatstone bridge is we can see a positive or negative value. This makes for a very useful and informative sensor. If I were to substitute the LDR with a piezo-resistive strain gauge, I now have a very accurate pressure sensor. I'll trim the circuit first. When I flex the resistor, it can be seen that not much is happening. I'll go down to millivolts. Now when I flex the sensor, we can see a very accurate voltage measurement. Because this signal is very small, it will need to be amplified. As you can see, any change made to the sensing resistor will now be read as a much higher voltage. Most automotive piezo-resistive sensors have 3 terminals: high reference, low reference and signal output. These sensors can be tested easily. In this example, I have a meter connected to the signal terminal of an air conditioning pressure sensor. As the pressure increases, so does the output voltage. On this map sensor, I have connected the meter to the signal terminal. Again, you will see a voltage change with pressure. That's piezo-resistive sensors explained. They are not complex, yet provide valuable information for the engine management system. Understanding how each component works makes diagnosis easy. Thanks for watching.